What's up, everyone? This is LeetCode 169, majority element. We've done this problem in Python, but now we're going to do it in C++. So we're given an array nums of size n, return the majority element. The majority element is the element that appears more than n divided by 2 times. You may assume that the majority element always exists in the array. So obviously, it tells us this, that it's always, that a majority element always exists. So that's neat because we don't have to handle like a strange edge case. So they make that problem, or this problem, a little bit easier for us because of this. Now, there's a few ways you can go about solving this problem. Some of them are less efficient. Like, for example, you have to find which element occurs more than n divided by 2 times, right? One thing you can do is make a hash map, and count the frequency of occurrences of each specific digit, right? Like, map the digit 1 to the number 3 because it appears 3 times, map the digit 2 to 4 because it appears 4 times. And so you iterate through the hash, or you go through the hash map and you check what value for each key, what value occurs more than n divided by 2 times, and then you return the key, which would be 2, right? So you can do it in that way, for example, using a hash map, but of course that would not be O of 1 space, right? Because the follow-up asks us to solve the problem in linear time and O of 1 space. So to solve this problem in linear space, we're going to use something called the Fourier algorithm, right? And this algorithm isn't that intuitive or easy to come up with on your own, so don't feel bad. I didn't come up with this algorithm on my own the first time I encountered this problem. But there is a way to basically solve this problem in O of 1 space. And so kind of the premise or the idea behind the algorithm is that you're going to basically track what the majority number is you've seen so far and the count, right? So for example, when the count's initially 0, you're going to set the number you encounter next as the majority element. So for example, the count initially, right? Let's just make this here. Then this would be the majority. We'll call it the majority number. Okay, so when count is 0, right? And we're gonna obviously have to iterate through this array. So I guess it's a vector, but we're gonna say I is less than n, I plus plus. Now, of course, we need to define n as well, and that would just be the length of the vector. So we're gonna say int n is equal to nums dot size. Vector array, same thing, right? At least in this context. So when like I said, when count is 0, right? The first element we encounter is going to be set to the majority number or the majority element. I'm just going to call it majority number, but it's the same concept, or it's the same thing. So the majority num is going to be equal to nums of I, and the count is going to go up by 1. Okay. Now, there's also another case, which is where there's 2 other possible cases, right? So we encounter this too. This gets set as a majority number, and the count goes up by 1. Now, we can, when we go to the next number, it's going to be one of 2 conditions, right? Either this number is going to be the same number as the one we previously had, or it's going to be different, meaning we had a 2, right? This next number is either going to be a 2 also, or it's going to be some other number, right? Doesn't matter what other number, but just anything other than 2. So let's handle those 2 cases. So we're going to say if nums of I is equal to the majority number, right? Now, if the number we encounter next is also the same as the previous number, we can just increase the count, okay? If it's not though, right? Let's say, for example, this third number in the array, right? 2. When we encounter this 1, we can just decrease the count, right? Because it's almost like undoing the number we've seen, right? And then this is basically the premise of our algorithm, okay? So really the idea, right, in totality is that you're checking which number well this count really is an important condition because it's going to set your majority number. And when you encounter a number that's not the majority element, you undo it, meaning you set the count down, you decrement the count, right? And if you decrement the count enough, then the next number you encounter is going to be the new majority element, right? Right? For example, right, when we could have this 2 and this 2. So the majority element is 2, and it happened twice. Now we encounter this 1. The majority element is still 2, but the counter gets decremented to 1, right? Which makes sense, because this 1 undoes this 2 in terms of, you know, checking which is a majority number. Now when we encounter the second 1, our count's going to be 0, because it's almost going to undo this other 2, right? Also, because at this point, we have 2 2s and 2 1s. So right now, we don't have a majority element, right? They both occur the same amount of times. So the next number we encounter, the count's obviously going to be 0. So this is going to be our new majority element, okay? And so we set that here. The count goes up by 1. So 1 is our new majority element. Then we encounter this 2. This 2 undoes this 1, right? We decrement the count. Count is equal to 0, which makes sense, right? Because up to this point, we have 3 2s and we have 3 1s, right? So we don't have a majority element right now, right? So the count is equal to 0. So when we encounter this next 2, the count is 0, so we set that as the majority element. Count goes up by 1. We exit the for loop. We return the majority number, which is going to be 2, which makes sense, right? Because up to here, no number occurs a majority. There is no majority element. We have 3 1s and 3 2s. Here, though, we have a 2, and it doesn't get canceled out by any other number. So at this point, right, this gets set as a majority element, and we return, and that's what we get, right? And, you know, it's kind of an elegant algorithm, but it's not very easy to come up with on your own. At least for me, it wasn't the first time I encountered this problem, but it's an interesting problem. But yeah, pretty elegant, but a little bit hard to come up with on your own. If you came up with it on your own, then you know, congrats, but I certainly didn't the first time I encountered this problem. But anyways, I hope this helped, and I'll see you in the next one.